People, welcome to the second video on the heap data structure. So today we're actually going to implement that heap data structure in the Go programming language. And the first thing that we want to do before we do that is I realized I made a typo in my last video. So instead of FMR, it's FMT, so it's format.println. So we'll just change that, save it, and now we're good to go. So let's go into our heap folder, which is empty, and create heap.go. So we'll just go ahead and start creating that right off the bat. So we'll create a heap package, and we'll want to import all the things that we want to use. So we're going to use string conversion, and that'll be useful for converting our heap to a string. So let me pull up my notes, and what we'll do is let's first create our heap data structure, and it will be heap struct, and what it will be is it's just a slice of integers. Very simple. And let's go ahead and create the print function, or the stringer function for our heap. So we'll create heap string, and we'll return a string. And let's start by creating a string, an empty string. Then what we'll do is for each number in our I want to keep calling it an array, but it's a slice. Each number in our slice, what we'll do is we'll append that number, and we'll use the I2A, the integer to alpha numeric function, and we'll just add a little comma in there, and then we'll return the string that we created. There we go. Now we can start writing our core functions. So let's write a heap insert function where we will insert a integer, and the way that we do this is very simple. We append the integer to our slice, and then we actually call a private function called upheap. And what upheap does is it takes the number at the very end of our array and bubbles it up to its proper position in the heap. So let's go ahead and create that function. So it's not too long. So we'll do heap upheap, and what we do is we get a position, which will start with the end of the array, so length of data -1, and then we'll have an infinite loop, which we do by just having an empty for loop, and we get the parent value. So which will create a function called parent, which will calculate the parent position of our from our current position, and if our parent equals -1, if our parent position equals -1, then what we'll do is we'll return, because we know we can't bubble up any further. I mean, we know that we're done. If our data, let's see, so if the value of our parent is greater than the value of our current position, then what we'll do is, we will also return, because we know that we're done. And otherwise, we will do a swap between the parent value and the value at our current position. There we go. And then we return, or actually we make our position equal the parent. And that's a nice little iterative algorithm to solve that problem. So let's see, what else should we create here? Let's create let's create a top function, and this function will allow us to see whatever is at the top of our heap without modifying the heap at all. So we'll call it top, and it will just return, let's see, returns an integer, and we'll return hData at position 0. Now let's see, another thing that we might want to do is we might want to remove something from our heap. So let's create a function to remove a value. So let's create heap remove, and we'll remove a certain number. Let's get a position. So we'll write another function called find, which will give us the position of the value that we're looking for. And if the position does not equal -1, where -1 means that it wasn't found. So if it doesn't equal -1, then what we'll do is we'll get the value at our position will equal the value of the last element of our array, because we're going to be deleting stuff. So what we do is we take the last item in our heap and we put it into that position where we want to delete it, so that way we've gotten rid of the other thing that we don't want anymore. And we also shorten our slice, so data now equals length of hData -1. There we go. And then we also, now we call a function called downHeap that we're going to write. And what downHeap does is it takes a position in the array, and then it takes that node and it bubbles it down to the position where it should be in the heap. So that's pretty neat. And that's pretty much it for removing an element from the heap. Let's also, while we're at it, we'll create a function that will pop off an element, the top element of the heap. So instead of having to say remove 0 all the time, we can just do a pop, and it will return the top element if we want it, and it will also remove it. So let's save the top element by doing htop. Then we can remove the top element and return t. Right? That makes it very easy. All right, so now that we've got that out of the way, let's create our find function. So let's do function heap, and we'll create find, and it's a private function because it has a lowercase name. And what it will do is it will return, we're actually going to create a recursive solution for this, so we'll create a find helper where we give it the value we're looking for and the index that we're currently at. Okay, so let's go ahead and create that helper, heap. So we'll create find helper, and we'll give it a value we're looking for, position. They're both integers, and we'll be returning an integer position. So if our the value at our position is the value we're looking for, then we know that that's the position we're looking for, so we return it. If the value at the position is less than the value that we're looking for, then we return not found. So we return a -1 because we know we can't go any further down the tree and find what we're looking for, because we'll only get smaller numbers. Okay, so now what we need to do is if it's not what we're looking for, and we know that the other their current value is greater than, or than the value that we're looking for. Then we can look to the left and to the right on our heap. So let's do that. So let's look left. So the position of the left equals, let's h find helper. And we're looking for n number, and let's calculate the child. So multiply by 2 plus 1, that gives us the left. So if the position left is greater than or equal to 0, then we can return position left. We know that it was on the left side. Otherwise, let's look for it on the right side. H find helper. Looking for n, let's give it position times 2 plus 2. And whoops, okay. If position right is greater than or equal to 0, then we return position right, because that's the one that we're looking for. Otherwise, we return not found, which is -1. So that takes care of finding an element in the heap. And let's see, so we've already, let's see, what have we created so far? Let's go up here. So we've created up heap. Why don't we let's create down heap. So let's see, h heap down heap. And we'll give it a position, which is an integer. And let's do left equals position times 2 plus 1. And the right side equals position times 2 plus 2. So if the left side, or if the left position is greater than or equal to the length of our slice, then we can return. We know that we're done because if it goes beyond the length of the slice that we have, so we can't go any further. So that's why we return if h data of the, let's see, oh wait, if the right is greater than or equal to the length data, then we know that it has that if it's anywhere, it's got to be on the left side. So let's just do that. If h data left is greater than h data at our position, then we know we can do a swap. We know that the right place for our data is now going to be on the left side. So we swap by doing h data position, h data left. Right, there we go. And then we also call a down heap on the left side. Otherwise we know we're done, so we return. There we go. So now what we can do is, let's see, so if it's let's see, so now what we need to do is we need to check if let's see, so now we know that it could be either on the left side or the right side. So what we'll do is we'll check if the data on the left is greater than the data on the right. What we want to do is we want to pick the larger, in order to keep the heap property, we want to pick the larger side. So if the left side is larger than the right side, and our left side data is greater than the data at our position, then we know we need to do a swap at that position. So let's swap with the left, and that will equal h data position H data left. Okay, and then we know we need to do a down heap on the left. That takes care of that. And then let's see. Okay, else if H data right is greater than H data position. Let's see. Okay, then we do a swap with the right side. Data right, H data position equals H data position, H data right. And then we'll down heap on the right side, down heap right. And that takes care of that. Okay, that should be the end of that. And the other function that we really want to create is our parent function. We'll call it parent, and it just calculates what the parent value would be. Let's see here, we want to return an int. And so if the position equals 0, what we'll do is we'll return 0, because the parent of 0, or actually we'll return -1, because you can't get any higher than the root of the tree. Otherwise, we'll create a parent position, and it equals, let's see, position -1, and then divide by 2. And if the position mod 2 equals 0, then the parent will actually be position -2 divided by 2. Okay, so this one, so basically what we did is we assume that it's on the left side, but we check if it's the right side and set it that way. So it just saves us a couple lines, and then we'll return the parent position. Okay, so that takes care of that. So that's parent. And then let's see, are there any other functions we need to create? Let's see, so we created find and pop and remove and top and insert. That should be about it for the main functions that we need to create. So let's go back out here. Let's look at our main function. So we're creating a heap. We're inserting these values into it, and then we're printing our heap by turning it into a string. We're looking at the top value. We're doing a pop, which will test our remove function and our find function, and then we'll print it one more time to look at it. So let's take a look at that. Let's do go run main, and there we go. So it put our items into a heap. So 70 is at the top, and then its left side is 20, its right side is 50. And then the children of 20 are 12 and 17, that's good. And the child of 50 is 30, that's good. So we looked, and the top value is 70, that's great. And then we removed the top value, so now we get a tree where 50 is at the top, so that's good because the next highest value is 50. And the child of 50 are 20 and 30, that's good. And so the children of 20 are 12 and 17, and that looks pretty good. So that's about it for the implementation of the heap data structure. And there's all kinds of other functions you could actually add on, or methods that we could add on to our heap. But those are pretty much the core that you want to work with. And so that's it. Thank you for watching. Till next time.